in the setting of full relativity with speeds close to the speed of light, then it can be shown that the Newton's third law is inaccurate. However, in the regime of classical physics, where the speed is not so close to the speed of light, and the period of an orbit is rather long compared to the size of the orbit r divided by c, then it can be shown that the Newton's third law is perfectly valid. And here are the forces for classical situation with small speeds. So just the ordinary QE and the ordinary magnetic field given here. So let's look at the more general situation, not the circular orbit. Let's look at the elliptic orbit. Different masses, M1 and M2, different charges, Q1, Q2, but a negative sign here, so at least you have a bound system here. So we can look at what is the electric field here because of that charge, and what is the electric field here because of that charge. So we have those expressions done, and you can see that then you can write it like this, that there is a relation between the electric field E1 and E2. And also for a two-particle system, in the center of mass frame, it is easily shown that the velocity V2 is related to the velocity of V1, like this. And by inserting this knowledge here and that in the expressions here, you can sum those forces, and indeed they equal zero. So Newton's third law is valid in this case, and it can be shown to be valid for any situation of two charges, Q1 and Q2, not only bound system, but also unbound. And further, it can be shown for n charges in a full electrodynamic situation, that Newton's third law is still valid as long as the charges are moving slowly.